So if you're given the graph of the reciprocal and you have to find the original one, they're going to tell you a hint in the question whether it's a line or a parabola. This one's telling us a quadratic function, so we know we have to graph a parabola. The same thing we did with lines is, what was the first point that we graphed when we did a line? The intercept, the x-intercept, right? Where is the x-intercept going to be? No. How do we draw, if we have an x-intercept on our original graph, let's go back to one we did. Here we had an x-intercept here and here. What happened to those points on a reciprocal? They disappeared and they became asymptotes. So now if we're working backwards, as we are in this question, we have an asymptote. Where we had an asymptote, that will become an x-intercept. Wherever there's, we get asymptotes from x-intercepts. So if we're working backwards, if we have a vertical asymptote, we'll draw an x-intercept.
One vertical asymptote, there's only one x-intercept?
There's only going to be one x-intercept.
That would be the vertex?
Probably going to be the vertex, yes. Okay. If we look at a point on our red graph, so you're going to go through this. I'm going to label, looks like this one is at -1, 1/2. If you did the reciprocal of 1/2, what would you get? 2/1. So I'd have the point -1, 2. Over here as well, I'd have the point -3, 2. Based on the fact that right here, I have the point -3, 1/2. That's already enough to draw a parabola. But I want you to think, when you're drawing this parabola, there are always points where our original graph and our parabola intersect. I'm going to go back to an example here before. Can you see that the two graphs intersected right there when we graphed example 2? If we go to example 1, can you see that the two graphs intersected right here? What is important about the y-coordinate when they intersect? If the y-coordinate's going to be the same, and one of them's one number, and the other one is 1 over that number, what has to happen? What has to happen to the y value? The only way that y is equal to 1 over y. That's where the two graphs intersect. Can you put a number in there? Sure, y could be 1. What also works? No, half will be 2. That won't flip the same. Can you see that -1 also works? In math, we have a word for this when you have a point on one graph and you do something to it and it doesn't change. We call it an invariant point. The word vary in English means to change, and the word in front means not change or not vary. So if you went on here and you looked right here and here, I don't even know what the x values are, but I know at those points y won't change because the y value is 1. Now I really have enough information to draw my parabola. So let's look at the second one. How did I get the vertex there? Because it had the asymptote. Second one. Are we going to have any x-intercepts on our parabola? 2 of them. Here and here. This point is nicely labeled for us. It's at 0, 1/2. What's going to happen to that point? It's going to be 0, 2. That's already enough information for you to graph your parabola. You could be done. But let's look for invariant points. Is there any places where the red graph is equal to 1 for your y value? Can you see right here the red graph has a y value of 1? Right here the red graph has a y value of 1? So you could draw those points in as well. Are there any points where your red graph has a y value of -1? So you look at -1, does that ever hit the red graph? Sure does, right here and right there. So we really have lots of information for this one to graph our parabola. We can only label this point 0, 2 and 1, 0 and -1, 0. Those are the only points that we can for sure label. But we can draw those other points as well. If you were then asked to write the equation of the graph, can you see that we know the vertex is at 0, 2, so it'll be x squared plus 2. It's going down, so we know our a value is negative. And since we went over 1 down 2, we know that our a value is -2. So the equation for this one, just a little review since we're getting close to the final exam anyways, we get -2x squared plus 2. The second one, you can see that the vertex is at -2, 0. So I'm going to just start. You would have x plus 2 squared plus 0. I'm putting all the stuff in. You wouldn't need to write that plus 0. Our a value is going to be positive, and we go over 1 up 2, so our a value will be +2. So this one would look like, you could also get the a value by plugging that other point in, -1, 2. Since it was so easy to go over 1 up 2, but if you didn't have a nice point, you would put a in and plug that point in to find it. And the last question of the year for practice, and then your reviews, is just number 9.
And that's the end.
So I will try